Hello everyone, myself Prayat Patel, working as Assistant Professor in IT ICT Department of LJ Institute of Engineering and Technology. Now in today's video lecture, I will discuss about the next topic, polynomial reduction and approximation algorithm. Now first we understand what is the polynomial reduction or why we require the polynomial reduction. So we already understand what is the P problem, what is the NP problem, what is the NP complete and what is the NP hard. Now for classifying the NP problem, this NP problem is a NP complete or NP hard, we require the polynomial reduction. So here basically polynomial reduction first step is a given an instance alpha of problem A, use a polynomial time reduction algorithm to transfer it to form of the instance beta of the problem B. So see in this figure, first input is alpha of the problem A, and after applying the polynomial time reduction algorithm, we will get the result as a beta of the problem B. Now second step, run the polynomial time decision algorithm for B on the instance beta. So after performing first step, our output is beta. Now beta output consider the input for the next step. In next step we apply the polynomial time algorithm to decide B. So here answer is like yes or no. So third step is use the answer of beta as the answer of alpha. So here our answer is yes or no. Decision problem like this. So this is called the polynomial time algorithm to decide A. So in other words, we can define the polynomial reduction as a by reducing the solving problem A to the solving problem B, we use the easiness of B to prove that easiness of A. So this is called the polynomial reduction. Now why we use the polynomial reduction? Why we require the polynomial reduction? So to prove whether the particular problem is NP complete or not, that means NP complete or NP hard, we use the polynomial time reduction. That means this is applicable for the NP problem, not applicable for the P problem, because here we use the word like for the check NP problem is NP complete or NP hard. So we use this method or technique for solving the problem or check the problem given problem is NP complete or NP hard. For example, if the given problem is traveling salesman problem, then we can say that for checking the traveling salesman problem solution, this traveling salesman problem is NP complete or NP hard, we check using the polynomial reduction technique. Now here understood this thing using the graph. Now first step of this process is every problem in NP. That means this algorithm, this step applicable for the NP problem. So first step is every problem in NP. Now after that, next is a circuit set. Means from the given set, for the given problem, we have to first design the one circuit is called the circuit set. Now after creating the circuit step, next step is a CNF set. Now after CNF set, we have to find the 3 set. Now after the 3 set, next step is a vertex cover. Now we will discuss each and every step in our next slide. But here our step is like this. First every problem in NP, then circuit set, then CNF set, then convert into 3 set, then convert this into the vertex cover. Then this all remaining step is considered as a different problem that can be belong into NP class. So click Q problem, set cover problem, subset sum problem, knapsack problem, Hamilton cycle problem, traveling salesman problem. These all are the example of the NP problem. So this technique, polynomial reduction, applicable for this type of problem. Now we understood one by one step. Now first step in this figure is circuit set. Now what is circuit set? Circuit set means we have to create or design one circuit like this. In this circuit we can use the AND or NOT, different type of nodes. So here input as a, for example, A, B and C. Then next D is considered as a exclusive or B, like this. So here we use the OR gate, then XOR gate, then XOR, then NOT gate, AND gate, OR gate, NOT gate, like this. So for the given problem we have to construct this type of circuit. It is called this circuit set. Now next step is CNF set. Now what is the CNF set? CNF set is a based on the Boolean formula. So Boolean formula depend on the such type of operation like and or not. So we already defined the gate, AND gate, OR gate, NOT gate in previous slide. So here we use the some symbol for the AND, OR and NOT like this. So for NOT we can use the bar, for AND we can use the multiply, for OR we can use the plus symbol. So this type of symbol can be used in form of CNF. A Boolean formula is called the CNF. CNF, that means conjunctive normal form. It is in the form of collection of clauses. So our given data in form of collection of clauses, then it is called the CNF. For example, here A plus B bar plus C plus D. So this first bracket is considered as a first clause. Now second clause is C plus E bar. Now third clause is B dash plus D plus F dash plus B. So here three different clauses are given. So collection of clauses is called the CNF set. And in this CNF set we can use the plus as a OR, dash or bar as a NOT, and multiplication of two clauses is considered as a AND operation. Now after the CNF set, next step is a 3 set. Now what is this 3 set? In CNF set, not any condition like each and every clauses require the how many number of elements. So in this previous example, CNF set, first clause is having a 4 literals, second clause is having the 2 literals, third clause is having the 4 literals like this. Now in 3 set, each and every clauses require exactly 3 instance, means exactly 3 literals. So definition of the 3 set is a 3 set problem is a problem which takes a Boolean formula in CNF form with the each clauses having exactly 3 literals. So for example, here we can write the A plus B bar plus C into C plus E bar plus F into B bar plus F bar plus B. So this is considered as a 3 set. Each and every clauses compulsorily require 3 literals. Now after that, next is a vertex cover. Now what is the vertex cover? A vertex cover problem is to find the vertex cover of the minimum size in a given graph. So vertex cover, that means each vertex covers its incident edges. For example, here this is a given graph. Now for this graph, how we can find the vertex cover? So for that, first we select the any node. So for example, here we select the node number A as a starting node. Now after selecting this particular node, we have to select the one another node and with connected edges. So here A to B edge is considered and node A and B as a selected node. That means node A, node B and one edge between A and B are selected. Now after that, all the connected edges with A and edges connected with B all are removed or ignored. That means here connected edge from A to C is ignored. Dashed line is considered as a ignorable edge. Now next, B to D edge is also ignorable because here we consider A and B as a selected. So all the edges connected with A and B are ignored. So here these two edges are ignored. Now after that, once again we have to select the one node as a new starting node. So for the remaining nodes C, D, E, F and G, out of these 5 nodes, select any node as a starting node. So here we select the C as a starting node. Now after that, select the one another node and one edge between these two nodes. So here C to E edge is selected, node C and node E is also selected, and here this is considered as a selected node and selected edges. Now after that, all the connected edges of the C and E are ignored. That means here we consider this 4 edges is connected with C or E. So ignore this all the edges. Now here we can say that after this process we have to select one remaining node. So here remaining node is D, G and F. So here we select the node G. Now select one edge and one node connected with G. So D to G edge is selected and node D and node G are considered as a selected node. Now here this all yellow shaded node is considered as a selected node and F is not considered as a selected node. Now for that, here what is the vertex cover? So all the yellow shaded node is considered as a set of the vertex cover So A, B, C, D, E and G is considered as a vertex cover element of the set as a vertex cover. Now, when we can say that this problem is a complete problem, that means NP complete problem, and when this problem is a NP hard problem. So for that, if we cover all the nodes of this given graph in our vertex cover set, then we will say that this is a NP complete problem. If we not find all the node in this vertex cover set, then we can say that this is a NP hard problem. So for example, for this example, F is not included in set of the vertex cover. So we can say that this problem is a NP hard problem. This is a traveling salesman problem. So this is a NP hard problem because F is not visited in any way. So in this case, we can define particular problem is a NP complete or NP hard using the polynomial reduction technique. Now, so many problems are available for the NP problem, like traveling salesman problem, Hamilton cycle problem, click queue problem. So here we understand one problem as a click queue problem. Now in click queue problem, the click queue problem is the computational problem of the finding the click queue, means subset of the vertices all adjacent to each other, also called the complete subgraph in a given graph. So here this all the different figure is represented as a click queue. So click queue size, what is the click queue size? Number of element, number of node available in this click queue is called the size of the click queue. So here in first figure, 4 node is selected, so click queue size is 4. Second figure also 4 node, third figure also 4 node, like this. So here we can say that the click queue size equal to 4. Now next definition is maximum click queue problem. The largest size click queue is called the maximum click queue problem. So we have to obtain the largest size click queue. So here last is considered as a last figure considered as a maximum click queue problem. Now after that, next topic is a approximation algorithm. Now what is the approximation algorithm? Why we require the approximation algorithm? Because for each and every problem we have an actual algorithm. For example, for the quick sort we have an actual algorithm. For the merge sort we have an actual algorithm. For the traveling salesman problem also we have an actual algorithm. So for each and every problem we have an actual algorithm. So why we require the approximation algorithm? Because here approximation algorithm find the solution very quickly. Without having all the information, we can find the solution using the approximation algorithm. So find the approximate solution, we can use the approximation algorithm because actual algorithm always give the actual solution, perfect solution. Approximate algorithm give the approximate solution. So find the approximate solution, we can use the approximation algorithm. In another way, we can say that find the good solution fast. Using the approximation algorithm, we can find the good solution, not as a best solution. So for finding the good solution and very quickly, we can use the approximation algorithm. Now following two algorithm is considered as a approximation algorithm for the problem traveling salesman problem. So first algorithm is a nearest neighbor algorithm for traveling salesman problem, and second one is a twice around the tree algorithm for the traveling salesman problem. Now we understand these two algorithms one by one. Now first is nearest neighbor algorithm. Now here this problem is considered as a problem of the traveling salesman problem. So traveling salesman problem means salesmen have to travel all the cities without repeating any city, and your starting city is same as your ending city. So your source node is same as your destination node. Now here in this example, A, B, C and D, this 4 node is considered as a 4 different cities. You have to start from the city A and you have to reach to the city A with covering all the nodes only once. Now here first algorithm for solving the traveling salesman problem as a nearest neighbor algorithm. Now here nearest neighbor algorithm solution is like here first starting from the node A. So A to 3 path is possible, A to B distance is 2, A to C distance is 4, A to D distance is 7. Now which neighbor is a nearest neighbor? So A to B is nearest, so select A to B. Then from B to 2 node is available, D and C. So C is nearest, so select B to C. Then after C to D, then after D to A. So our path is A, B, C, D, A, and distance equal to 2 plus 3 plus 2 plus 7 equal to 14. So this is a solution using the nearest neighbor algorithm. That means using the approximation algorithm. Now, what is the optimal solution? What is the best solution for this given problem as a solution of the traveling salesman problem? Now, best solution is A to B, B to D, D to C, and C to A. And distance is 2 plus 4 plus 2 plus 4 is equal to 12. So, optimal solution is equal to 12 and approximation solution is equal to 14. So, this approximation solution is near to our original solution. So, we can use the approximation algorithm in these cases when we require the fast solution. In this case, we can use the approximation algorithm. Now, second approximation algorithm for the traveling salesman problem is twice around the tree algorithm. Now, see here, this graph is given as a problem of the traveling salesman problem. Here, 5 cities A, B, C, D, and E is given. All the distance is also given. Now, how we can find the solution of the twice around the tree algorithms? So, first step of this algorithm is obtain the minimum spanning tree for this given graph. So, in this graph, minimum spanning tree is like this: A to B, B to C, then B to D, then D to E. Distance is also given. So, this is called the minimum spanning tree. We can use the Prim's algorithm or Crystal algorithm for finding the minimum spanning tree. Now, after that, next step for finding the solution for the twice around the tree algorithm is step number 2. Step number 2 is start from the node A and visit the DFS walk around this tree. So, you have to visit or move in this tree 2 times. That's why we can say that the twice around the tree. So, here we start from A, then A to B, then B to C, then C to back to B, then B to D, then D to E, then E to D, D to B, and B to A. So this red shaded line is considered as a twice around the tree. So move in this tree using the DFS. So according to DFS, we move from A to B, B to C, C to B, B to D, D to E, E to D, D to B, and B to A. Write this sequence as a path for this answer. So this is a path for the twice around the tree. Now, what is the solution for the traveling salesman problem? So here, eliminate the duplicate entries in this path. So here, first is A, then B, then C. Now B is repeated. So remove this B. Next one is a D, then E. Then B is also repeated. So remove this B, and next one is a A. So here our answer is A, B, C, D, E, A. So this is a solution for the traveling salesman problem using the twice around the tree algorithm. So in this lecture we discuss about the how we can find the solution using the approximation algorithm. So we have used the 2 methods for solving this approximation algorithm for the traveling salesman problem. Thank you for watching this video.